So today we're going to build on what we've been doing. We've been talking about solving using square roots. And today we're going to talk about how we can use what we have been doing, this square root idea, in order to solve any equation if we can get it into vertex form. If you notice, this last equation up here in the solving using square roots section is actually an equation in vertex form. You have like x minus h squared plus k. So this is actually in vertex form. So if we can get it in vertex form, we can set it equal to 0, get the k over on the other side, and then square root both sides to get our two equations that lead to our two answers. So if we can get the equation in vertex form, we can use square roots. And if you have an equation in standard form, the way that you get it into vertex form is by completing the square. So today we're going to talk about the bottom of the front of the last page of your notes. It says solving by completing the square. The gist of this is that if you can put it in vertex form by completing the square, then you can solve it using square roots exactly like we did for the past few days. So let's look at this first one. Let's first put it in vertex form. So in order for this to be a perfect square trinomial, so we can write it in like this part of it here with the x plus or minus something squared, it needs to follow that pattern. And to get that pattern, this number needs to be half of this squared. So I'm going to come over here. Half, let me zoom in a little bit here. Half of 6 is 3. 3 squared is 9. So that should be a 9. In order to make that a 9, we have to add 4, because 5 plus 4 is 9. So I'm going to rewrite that as f of x equals x squared plus 6x plus 5 plus 4, and then minus 4. So this becomes our 9. So now I have f of x equals x squared plus 6x plus 9 minus 4. Now I have, this is the perfect square, that's x plus 3 squared, and then you have minus 4. So now that we've completed the square, now it's in vertex form. Now we can use that to solve using square roots. So to do that, I'm going to put a 0 where y is because I want to find the solutions. So now I have that. And to solve using square roots, now it's exactly like we have been doing. We need to get the squared part all by itself. That's called isolating the squared part, because isolating is getting something by itself. So we're going to isolate the squared part by getting it by itself. So we have to get rid of this minus 4 that's not being squared. So we're going to add 4 to both sides. So now we have 4 equals x plus 3 squared. Now everything over here is being squared. There's nothing over here that's not being squared. So now we can undo the square by taking the square root of both sides. I'm going to come up here now. So we end up with the square root of 4 is going to be plus or minus 2 equals x plus 3. Because the square root and square cancel out. So now we just need to solve these two equations, because if we're going to subtract 3 from both sides, do we subtract 3 from a positive 2 or do we subtract 3 from a negative 2? We don't know. The answer is both. So we're going to have 2 positive 2 equals x plus 3. And when we do that, we subtract 3 from both sides, so x is negative 1. And we have negative 2 equals x plus 3. Oops, so we subtract 3 from both sides. And x is negative 5. Okay. Now let's look at the next one. Same idea. We're going to first get this into vertex form. So we take half of negative 2, which equals negative 1. And then we take negative 1 and we square it. And we always put the negative 1 in parentheses, or we're not going to get the right answer. We want to square the negative also. And that equals a positive 1, so that should be a 1. So to do that, we have to add 8 and then subtract 8. So now we have f of x equals x squared minus 2x. That's the 1, so plus 1. And then we have the minus 8 on the end. So this is now our perfect squares. So we have x minus 1 squared, and this number is always just half of that number, minus 8. And now that it's in vertex form and looks like this, we can just solve it using square roots. So if we want the solutions, we always put 0 in for y. And then we have to isolate the squared part, get it all by itself. So we add 8 to both sides. So we have 8 equals x minus 1 squared. And then we square root, and you get plus or minus square root of 8, and we can just leave it as that because if you do the square root of 8, you get a decimal, equals x minus 1. Now to solve for x, we have to add 1 to both sides, but do we add it to a positive square root of 8 or a negative square root of 8? We don't know. And so what we're going to do is we are going to add it to both. And so we have a positive square root of 8, equals x minus 1. And then when we do that, we add 1 to both sides. So we have a positive 1 and a positive square root of 8 equals x. We can't combine them together because this has a square root and this doesn't, and so you can't really put those together. And I'm going to write the positive 1 first, so that way it doesn't look questionable as to whether or not the 1 is also like underneath this square root here. Okay, so that's my first answer, 1 plus square root of x. And then my other answer would be negative square root of 8 equals x minus 1. So I add 1 to both sides there, and now I have a positive 1 and a negative square root of 8. Again, I can't combine them, so I just leave them as two separate things, the 1 and the negative square root of 8. I'm going to put the 1 first, so it's not a question as to whether or not it's underneath my square root, equals x. Okay. And now the last one. Half of 8 is 4. If you square 4, you get 16, so that should be a 16. Oops, there you go. So that should be a 16. So to make that a 16, we're going to add 5, and then we're going to subtract 5. So when we do that, we get f of x equals x squared plus 8x. This 11 plus 5 here, that's my 16. And then I have this minus 5 hanging out there on the end. So now I can write it in vertex form because this is the x minus h part. That's my perfect square, and that's going to be x plus 4 squared. Then I have this minus 5. Now that I have it in vertex form, just like I did here, and I got it in vertex form right here, now I have this one in vertex form. Once it's in vertex form, now I can start solving using the square roots just like we have been. So I'm going to add, or first I need to put 0 in. Okay, so first we have 0 where the y is because the solutions happen when y is 0, the x-intercepts. And then I'm going to add 5 to both sides. So I have 5 equals x plus 4 squared. And then I'm going to square root both sides. So coming over here, I'm getting plus or minus the square root of 5 equals x plus 4. Now when I solve that, I need to subtract 4 from both sides. So am I going to subtract 4 from a positive or a negative square root of 5? We don't know. So we're going to do both. Well, I guess the answer is both. So we have a positive square root of 5 equals x plus 4. So if I subtract 4, that cancels out. So now I have a negative 4 and a positive square root of 5 equals x. That's one solution. And I'm going to put the negative 4 first. because that way it's not questionable as to whether or not it's underneath my square root with the 5. And then I have a negative square root of 5 equals x plus 4. So I'm going to subtract 4 there. And then I have negative 4 minus square root of 5, because they're both a negative now, equals x. Sorry that there's not a lot of room there. Apologize for that. I probably should have given more room at the bottom of that page. But that is how you solve by completing the square. It's nothing new. It's just what we learned a few weeks ago with how to complete the square, and then what we've been learning for the last 2 days on how to solve it using square roots. It's just combining the two things together. So first you complete the square, then you solve using square roots. And that is how you can solve a quadratic function using completing the square.